The chain rule, part 1. This sounds a little bit scarier than it actually is. Chain rule is used when you have a function that's what we call a composite function. In other words, one function inside of another function. And the function I have at the top of the screen here, f of x is 3x plus 1 squared. The outer function is the square, the inner function is the 3x plus 1. Now, we can take the derivative of this already by multiplying out the 3x plus 1. You get 9x squared plus 6x plus 1, not just 9x plus 1. Be careful there. And then when you take the derivative using the power rule, you get 18x plus 6. We've been doing that for a little while now. But what if we just use the power rule without foiling the polynomial out? You might try this. That's why I get a question mark. We're not sure this is right. But let's see. Does the derivative of f equal 2? See, I brought the power down. I brought the 2 down in front. Times 3x plus 1 to the first power. That would be 6x plus 2. That's not the same as 18x plus 6. If you look, it's actually off by a factor of 3. So in math, if you try something two different ways and get two different answers, one of them isn't correct. We're pretty confident in the derivative of a polynomial at this point, so we think the 18x plus 6 is the correct derivative, and indeed it is. So what is wrong with the 6x plus 2, and how have we been misled into this? Notice it's off by a factor of 3. If I multiply 6x plus 2 by 3, I get the correct 18x plus 6. This is where the chain rule comes in. You have a function inside of another function. The outer function is the squaring. You have 3x plus 1 squared. The inner function is the 3x plus 1. The problem with this function is the derivative of what's inside is not a 1. When you do the 2 times 3x plus 1, what you're doing is finding how y changes when 3x plus 1 changes by 1. When you take the derivative with respect to x, what you want to know is how does y change when x changes by 1. And if you look, every time 3x plus 1 changes by 1, well, it means x only changed by a third. But every time x changes by 1, 3x plus 1 changed by 3. So if x changes by 1, 3x plus 1 changes by 3. That's where we get the chain rule. And I call the thing we add to the end the chain rule kicker, this factor of 3 that we encounter. So you begin the problem like we did in the second attempt. You bring the 2 down in front and you reduce the exponent by 1. But then you have to go back and multiply by what I call the chain rule kicker, the derivative of what was inside. What was inside was the 3x plus 1. That's what was squared. So I multiply 2 times 3x plus 1 times the derivative of 3x plus 1, which is 3, and I get 18x plus 6, which is the correct answer. The part that's the 2 times the 3x plus 1 just tells you how y changes when 3x plus 1 is increased by 1. But you want to know how y changes when x is increased, or as they say, with respect to x. Every increase of 1 for x is an increase of 3 for the expression 3x plus 1. This is why you have to multiply by the 3. In general, you will see this notation. If u is some function of x, the power rule works like this. The derivative with respect to x, that's what this notation means, of some function u to the nth power is n times u to the n minus 1 times the derivative of u with respect to x. The first step, the inside of the power function is part of the derivative. And the first step, the inside of the power function, right there, n times u. That u stays the same. You don't do anything to that when you're doing the power rule. You just do n times whatever was already there. In our case, it was the 3x plus 1 to the n minus 1. Then you multiply by the derivative of what was inside. But you will see that 3x plus 1, that was the original inner function, appear in your derivative. Okay, here's another example. If y is x squared minus 4x plus 5 cubed, how do I find dy dx, or the derivative with respect to x? Well, dy dx, I'm going to follow the power rule. The power is the outer function. The polynomial is the inner function. So I do 3 times x squared minus 4x plus 5. See the x squared minus 4x plus 5? It's the same as what's up there. And multiply that by the derivative of what was inside, which is 2x minus 4. You don't need to simplify this unless the problem says express your answer as a polynomial, which I don't think hardly ever happens. Sometimes it might be easier to simplify and then move on if you say had to take the second derivative or something like that. But for now, just leave it. If your answer is just give me the derivative, then this is a fine derivative. Okay, now what I want you to do is I want you to look at these problems at the bottom of the page here. And I want you to try to do these. Oh, one of them didn't come out very well. So don't do number 2. Just try number 1. Hopefully number 2 is better in the bottom. Okay, so let's try number 1. I want you to pause the screencast and try number 1. Okay, you're back. Did you really pause the screencast? All right, I hope so, because here are the answers. Here's the answer to number 1. 2x plus 5 to the 4th. The derivative was 4 times 2x plus 5 cubed times 2, which is the derivative of the 2x plus 5. I did multiply the 2 times the 4. You get 8 times 2x plus 5 cubed. Aren't you glad you didn't have to multiply that out to the 4th power and then use just the power rule? Number 2, I don't know why the problem didn't show up, but here it is here. Y was 2x cubed minus x squared plus 3x minus 5, all to the 5th. You would take the derivative the same way. 5 times 2x cubed minus x squared plus 3x minus 5 to the 4th. Notice the 2x cubed minus x squared plus 3x minus 5 shows up exactly as it was in the problem when you're doing that first step of the derivative. And then the derivative of 2x cubed is 6x squared. X squared is 2x, and the derivative of 3x is 3. And the derivative of the 5 is 0, which is why it disappears. Okay, well, thank you for joining us for this episode of Math Teacher to Go, Chain Rule Part 1. I have Chain Rule Parts 2 through 5 to follow. Good night.